Hi everyone, welcome to my YouTube channel Erudispace. I am Dr. Mohanty and today we will discuss about the Carnot Cycle. So Nicholas Sadi Carnot is one of the first to discuss about the second law of thermodynamics, and actually on the basis of his Carnot cycle both Kelvin Planck and Clausius could able to define the second law of thermodynamics. So what he has proposed an ideal cycle in which a working fluid undergoes series of processes at the end of which the initial condition is restored. So the cycle actually he has proposed consists of four thermodynamic processes. These processes may be represented both in PV as well as TS diagram. One, two, three, four. The same processes are represented in TS diagram. 1, 2, 3 and 4. So out of the four processes, 2 are reversible isothermal processes and 2 are reversible adiabatic processes. Process 1 to H, a reversible isothermal process. 2,3 is a reversible adiabatic process. Process 3,4 is again a reversible isothermal process. And 4,1 is a reversible adiabatic process. So out of these processes, 1, 2 and 2, 3 are your expansion processes. This is also expansion, and these two are your compression processes. Out of the four processes, 2 are reversible adiabatic or isentropic processes. So heat addition only takes place in process 1, 2, and heat rejection actually takes place in process 3, 4. Now, to analyze this, first let us consider a piston and cylinder system having some amount of working fluid in that, and that would actually help us in understanding the Carnot cycle in details. So let us consider a piston and cylinder arrangement. You do have a frictionless piston with some amount of working substance, that is working fluid, present here. And the cylinder walls are actually perfect insulators. These are your perfect insulators. The cylinder head is made in such a way that it can either be a perfect conductor or insulator, perfect insulator. you have two thermal reservoirs. One is source, this is your heat source, and this one is your heat sink. This is maintained at temperature pH, and this one is maintained at temperature TL. Now, how the processes are actually taking place in Carnot cycle, that we'll discuss in details. Already the processes are represented in both PV and PS diagram. But how the processes are imagined to take place, that we'll analyze. First, this will come in contact with the heat source, and as it comes in contact with heat source, it will undergo a reversible isothermal process, and the heat that is being added in this process is Qs, and during this the cylinder head is made a perfect conductor of heat, so that there would be smooth transfer of heat from the heat source to the working substance. Another thing that you need to remember, that being an isothermal process, it will take an infinite amount of time because the temperature difference is 0. After that, this cylinder head is made a perfect insulator of heat. So, it would undergo a reversible adiabatic expansion process, and in this case no heat is supplied to the system, or no heat is supplied from the system to the surrounding. And after undergoing the reversible isothermal expansion and reversible adiabatic expansion, then this cylinder head would be made a perfect conductor of heat, and heat transfer will take place from the working fluid to the heat sink, and this is a reversible isothermal process. This is your heat rejected. And after that, you have the last of the processes, which is a reversible adiabatic process. In this case, again the cylinder head will be made a perfect insulator of heat. As a result, it will undergo compression, but there will be no heat transfer taking place from the working fluid to the heat sink. So, the entire heat addition takes place during process 1-2, and the entire heat rejection takes place during process 3-4. Now, what is Qs? From the Ts diagram, you can represent Ts as Th into entropy difference, S2 minus S1. This is Th and this one is TL. Already I have explained that this is the temperature that is maintained in the heat source, and this is the temperature that is maintained in the sink, and these are actually reservoirs of infinite heat capacity, so that transfer of heat from this or transfer of heat to this will not affect their temperatures. So this is TL multiplied by S3 minus S4. And all of us know that both 2-3 and 4-1 are isentropic processes. So you can substitute this by S2 minus S1, because S3 is same as S2 and S4 is same as S1. Now we can find out the thermal efficiency of the Carnot cycle. The efficiency is always the net work output divided by the heat supplied. And we know that for a cyclic process, net heat transfer is equal to net work transfer. So this is Q net divided by Qs. So what is Q net? Q net is heat supplied minus heat rejected divided by heat supplied. Now, what will be eta? That is equal to Qs is Th multiplied by S2 minus S1 and Qr is TL multiplied by S2 minus S1 whole divided by Th into S2 minus S1. So now from this we get eta is equal to Th minus TL divided by Th. So some of the professors, they do represent this Th by T1 and this TL by T2. But deliberately I have not done this because you have two processes which are isothermal processes, and so T1 will represent both the temperature at point 1 and 2 and point 3 and 4. And those people who relate the temperatures to points, they may get confused. So it is always prudent that this is Th minus TL divided by Th, so that there would be no confusion. Always it is the ratio between the difference in higher and lower temperature to the higher temperature. So this is the performance of the Carnot cycle, and within the given temperature limits, this Carnot cycle actually gives the best possible efficiency. But there are certain limitations of the Carnot cycle for which the Carnot cycle is not feasible. Already I have told you that two of the processes are your isothermal processes. So for an isothermal process, you require an infinite amount of time for heat transfer to take place. And if you consider what we have considered while discussing the Carnot cycle, we have imagined that the cylinder head is made of such material that it can be made alternately a perfect conductor as well as perfect insulator. So that is not practically feasible because there cannot be any material which can be a perfect insulator and perfect conductor alternatively as per the requirement. And all the four processes are your reversible processes. Reversibility is a hypothetical concept because irreversibility is the law of nature. Although it is not practically feasible, it does have its advantage that you can compare the performance of any cycle with the Carnot cycle. Thank you very much for watching this video. Please do put questions if you have any doubt related to this. And don't forget to subscribe to my channel if you have not done so. Hope to see you soon for another lecture on my YouTube channel, Erudispace soon.